Okay, so on to our next speaker, who I have to say is probably one of the coolest startups that I've seen come out of Stuttgart for a long time. That's a company called asvin. Please welcome their CEO and the coolest guy in the marketplace, Mr. Mirko Ross, to the stage. The stage is yours.
Hi,
Thank you.
Thanks. Yeah, and thanks for being here. It's late in the evening, and I think it's for purpose to bring the cybersecurity guys almost at the end of the conference, because we are this kind of showstoppers for all this nice growth stories in AI. And now, yes, now it comes. Now we are going to the pains of the industry, the real pains. Okay, hacking AI. So just let me give you a brief introduction what we are doing with asvin in Germany. I need to take it on the right side. Great. Just a short profile. So what we are doing at asvin. We are focused on cybersecurity, particularly in supply chains, and data supply chains are very important. And however, if you look at AI, there are a lot of supply chains involved, not only data, as well the questions is how you're processing your data, preparing it for the training, then you have the models, how to distribute the models securely. So there are many topics in AI which are related to supply chains, which have led us to the conclusion that it's very wise to have a look on this. And we have started this rather early. I think it was now 4 or 5 years ago, where we were thinking about, hey, we think that the AI industry will run into a supply chain trouble, in the same supply chain trouble like the software industry towards cybersecurity. And this was before we had these discussions about ChatGPT and all this run. So we were starting to really deeply dig into the questions on how can we compromise AI systems, and what kind of lessons we can get out of compromising AI systems to make them more trustworthy at the end and more robust. And whatever we are discussing today as an industry, and I've listened to a lot of very good applications of AI, but we had as well this discussion about AI Act and all this stuff. So I mean, there are a lot of concerns out there, not only in Europe, as well in the US. If you had seen the meeting, the presidential meeting in the White House with all the Googles, the Microsofts, and the OpenAIs of this world, it's very obvious that trustworthy and robustness of this technology is an obstacle. If the industry will not getting towards this kind of stable foundations, unfortunately, regulation is stepping in, and regulation means, in this case as well, limiting all the possibilities we have as an industry. So building robust AI and trustworthy AI will be really a very important challenge for the future. So we were really early digging into the questions how we can compromise AI systems, just to get the lessons learned on how to build better and more safety-secure AI systems. There are several research projects we have carried out, mainly early starting with data poisoning. So the questions how we can inject manipulated data towards your training, your AI training, just to force the models to give a prediction we want to have as an attacker, and not a prediction which has been intended by the companies. So this was really the starting point. Then, of course, all these questions about adversarial attacks. I mean, this was getting very popular 2015, 17. If you look at the papers, 2022, we have really a peak of papers about adversarial attacks. So because many people are now stepping in, fortunately, because it's so easy, to be honest. And you can find very fruitful examples on how to manipulate AI systems by this. And now on a current project, we are working on with Antidote on the tools you can use within your machine learning development life cycles and your CI/CD pipelines you should have as an AI company, how you can integrate the tools just to depoisoning, for example, data inputs you're bringing into various machine learning models. So this is one scope, how we can depoisoning it. Why it is so important? Because obviously if you haven't trained your AI system, it's not trustworthy. There's no way to say, well, there's any trust in there. So If you can't fix it at the core, you need to take care that you fix it on the data level with the data you're operating with the systems. And that's one scope of the projects there. So just to give a people who are not part of this, like how you can manipulate AI systems, just giving you a short introduction on, well, what is the main idea on data poisoning and how it works. Usually it's the way that you say, well, I mean, you have your training data, you're training the model, you have a very, very, very great idea on what is the allowed statistical output of your model, where your model is in a certain quality level, like these red dots are out of the quality level, and then you do your training iterations to get the best fit of the accuracy of your model. On data poisoning, what we are doing is we are injecting data to your AI model on two levels. One level could be during the training, like placing backdoors in your AI models. Or a second one, for the adversarial attacks, we are just using the way how AI models are working on a neural network statistic systematic, and by that trying to flip certain neurons in your network, and then we can just move the output of the model as well in a certain direction. Which is very important. We don't want to move it randomly. Like, that's easy. I mean, randomly is just an error. That's what you have in your expectation every day when you're working with AI and you want to train it and to increase the accuracy. No, it should not be done randomly. We want to move it really in a certain direction. Because like we want to go, or we want to force your system to make an output we have intended. As an attacker, it's very clear. If you are working with AI systems who are operating as an attacker, we want to force the system to make a certain prediction, and by that to force it to make a certain decision. Later on, some famous, just giving you some famous examples, if you have an autonomous vehicle, you have a visual camera system, the prediction of the road signs. It's not only to manipulate the way how a road sign is recognized, we want to manipulate the way how the car is reacting. Should it stop, or should it just go full speed ahead over a stop sign? That's really a different. It's not randomly intended what we want to do, because that's just an error. We want really to force the system to go to a certain direction. And that's the way how you hack AI. Why it's such a great opportunity to do this? It's a great opportunity because, unfortunately, the AI industry is at the same level like the web industry in around the year 1998 or 1997. I mean, we have the same enthusiasm today. Oh, I mean, we have the same buzz as well, like it will change everything, blah, 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 for sure. However, but we are dealing with the same attitude than on that time. It was amazing, of course. People were building great applications. We had only a very limited set of tools where we can work with this kind of service and stuff like that. But for guys and ladies and others in this room who can a little bit remember the time there was a certain attitude, like you had been really lucky when you have built your first web application. You had been proud of that. It's very, I mean, a lot of knowledge you have to acquire, a lot of things, and then you have this kind of first web application. And in this case, it's one of these kind of web applications. We have this, like this Perl scripts where you have an online form. Someone was typing in something to an online form. The data has been submitted by a post request to your server, processed, and what happened, it was amazing. But nobody was thinking about, can I trust what people are entering there? Because the perception was, yeah, they will enter their name. Very good. What was the result? At the end, we had people who were not entering names. They were entering SQL commands to the input lines. So this was the beginning of code injections to our web server industry. And why? Because the developer had no intention that someone could put anything else than a name on a web form. There was no idea that someone would put in their SQL commands. or Perl script or whatever. So this was a lesson learned we had to take in the software industry. State of the art today in software industries that no developer in this world should trust any input data from any forms. He will never trust that. I mean, if he's doing that, to be honest, fire him, because that's not the way the attitude you should work as a software developer. So if you're getting data from online form, what you're doing, you're depoisoning the data. So you're doing escape commands on SQL injections, you're removing from the strings anything which could be maybe harmful. That's the way how we build software today. Software developers. Now, let's have a look on AI. AI is not a software developing world. Of course, there are AI people developing your core principles of machines. But however, it's a data analyst world. I mean, people working with data. People not used to be grown up in this hostile software developer world. People who need to take the action, or let's say the lesson, that data is never good. Data is never something you should trust. So, as an industry, we need to take the action that we need to depoison in data, whatever we are doing. So the question is how data analysts are looking on that. Well, you're looking on, yeah, well, I can't trust data, but of the question like, you have some certain errors in the data maybe. And then you are applying certain filters. But listening on that on a way that you need to depoison data because it could be manipulated from a really malicious attacker perspective is a new lesson we have to take. And with the rise of AI, we will learn it. Okay, just for the people who are new to the topic. I mean, this was one of the first very popular ways showing how adversarial attacks are carried out. And it's a really early example, I think 2015 or something like that, applied to the Google public image recognition. So what I've shown there was just simple, like you can use the Google model, which is a neural network, and you can force it to do very strange outputs, obviously. And the strange output was like, recognize what is on this image. And I mean, at that time, it was 57% to recognize a panda. To be honest, today, the Google model is much better. But that time, it was, let's say, 57% to recognize that this is a panda. The idea of this adversarial attack was that I can overlay a disturbance on a picture. And the disturbance is this pattern you see here. So it was a very rough method. It was like creating the disturbance pattern, calculating this disturbance pattern into the picture, which is just leading into a very, like the pattern is the mathematical overlay on a pixel, which leads into the situation that you can't see the pattern anymore as a human eye, because it's just really a slightly difference on a pixel. However, for the neurons in the neural network, for Google, it has a statistic effect. So, and the effect is like that certain neurons are flipping, and they're flipping, and at the end, for this example, it was then 99.3% confidence that this is a gibbon. And then I say, well, how can AI be so stupid not to recognize that? But at the end, this attack was pure mathematics inside. Now, this was 2015. Now, 8 years later, because this was very popular, of course, the way how we can apply adversarial attacks and how we think about how to defend it has really progressed. First of all, the models are better, so they are more robust. That's number one. But however, on the attacker side, we have done as well improvements on how to apply this kind of adversarial attacks. So, for example, one bad message is like finding this kind of patterns has been very, there was an intensive research on this to build mathematic models on creating such patterns. So we have really roughly automated it very good to find the right patterns to carry out adversarial attacks. And then as well the questions like, what is the size of the pattern? I mean, if you look here, It was a pattern completely over the picture. Now we can really shrink the size of the pattern for the disturbance, so it's really, let's say, only 16-bit part, or let's say 16 pixels in one side on a quadrant, which can be overlaid. So as well, the attacks have improved amazingly there. And as well, the question regarding these public models, how attackers can work with these adversarial attacks. I mean, this is a public model. This is an open source model, which is giving us as an attacker as well certain new perspectives on how to compromise the model itself. So the first question is, okay, I can put in now an optimized version of this pattern to flip the model to a very strange image recognition, number one. But what if I really want to not only put it into a gibbon, if I have a very, very great idea of what should be the output when I put a certain image as an input, and you, as someone who is building the model and who are doing the quality management, has no chance to find out that there's any manipulation in this model, because it will just the behavior of the model will completely unsuspicious. And the way how we are doing this is our backdoor attacks. So this can be applied on models, for example, if they are public models. You take these models and you retrain these models for your own purpose. Then attackers who are doing data poisoning injection, like manipulating your training data, have the ability just to manipulate the retrained model. And by that, I can do a so-called backdoor attack, which means if I know what is the right input pattern, I can immediately decide the way which neurons should be taken and used in the network, and by that create exactly the output I want. So, and this is a very, as well, let's say from the last 2-3 years, a very intensive area, how to design perfect backdoors, number one, and second, how you can mitigate risks of backdoors in models. And there are as well certain ways how you can mitigate this risk. At the end, we are all talking about robust AI. So, giving you a little bit a better understanding of what is the critical way of this kind of adversarial attacks. I mean, this is very rough. This was the way where people were putting stickers on stop signs just to force the image recognition here to make a wrong prediction. And this was very rough because you see the sticker. I will show you later on examples where you can't see anything like a sticker, and the models are as well going very strange and mad. But this was very rough. At the end, if you look like on the result of this, so this is the camera view of an autonomous car. You see one stop sign which is not recognized yet, but it has a sticker on it. If you go more near, it will be no more recognized as a stop sign, very sure as a person, which will lead into a completely wrong decision of the car at this moment. We talk later on how you can prevent from this kind of attacks, but these are attacks you can apply this kind of attack on any neural network model which has been not built and designed towards robustness against adversarial attacks. So this is not that the model has been manipulated, it's just a natural way how these models are built and how they are vulnerable. As I'm from Baden-Württemberg, there's another problem. We are just putting the stickers all over the world. It's not here in Baden-Württemberg. So maybe if you get road signs which are this way, it's distracting of what kind of the stickers will be adversarial attacks and what will be just the marketing stickers of my marketing agency of the Land Baden-Württemberg. There are as well, I think, very, very cool ideas where you can make money out of this. I mean, we have a big industry about recognizing people, all the surveillance industry, recognizing faces, recognizing people. And of course, if these systems are built and trained, and if there are lacking of robustness as well, I mean, they're just doing image recognition and they're trying to classify what they find on these images. So, of course, there are some as well very bizarre ways how you can deal with that. For example, this camera system, which has been built to recognize persons, it's very easy. You can just take this kind of adversarial T-shirt printing, and you are not getting recognized as a person anymore, but as a bird. One possibility. If you like to acquire such shirts and hoodies, here's the online shop, which will give you the opportunity to buy it for 60 bucks. And have a look if you go to Tegel, what they will tell you if you cross the security gates there. For facial recognition, we have seen as well some strange things like this people. This was as well from the, but there's a serious background. Of course, you can do the same for facial recognition. Just put on this disturbance patterns. To be honest, it looks very obvious, yes, but not if you go to the carnival. Maybe then you have a good chance that this will be not recognized. But there's of course a serious background in this, and let's say it in that way. This is a very rough way how you want to cheat the systems. What I will show you next is really the next level, because there you will see that it's, there are more now sophisticated ways how you can apply adversarial attacks. And this was an example Lab6 has presented last year. What I did is, well, they said, well, okay, we can do an adversarial attack, but we will do this on object recognition. So it's not only to do this on a flat picture. It's not only to have a road sign on it. We'll do that on 3D objects. And we will show you that we can fool systems, and again, it's the Google system which will be fooled here, to recognize a 3D object with an adversarial attack. And just showing you the example here. So this is a turtle, a 3D printed turtle, which is not manipulated. So it will be always, with a high perception, then recognized as a turtle. So if you turn the 3D object. Lab6 generated a 3D manipulated object, where the disturbance is part of the shape and the color of this turtle. And by that, they had the ability to fool the system as well on this 3D recognition with a very, very high precision. So you can, it's really like you can turn it in any direction, and the system will always recognize this not as a turtle, but as a rival. So this example will tell you is just simple, like if you think about, how to prevent my robust models from being compromised by adversarial attacks, be sure that the current state of the research is as well very far progressed. Like we are as well progressed on compromising your models in the way you are progressing on optimizing the way how you're building models. So this is really, really a very actual threat we are facing. And now we are coming back to this kind of online forums. Remember this 2000-ish online forum where people were just putting in their names into data. So the question is, like, if you are an AI developer, if you're a data scientist, how can I prevent from such stuff? How can I prevent this easy attacks? I mean, this Lab6 attacks, it's wonderful to see that you can do it. It's like someone is printing an SQL injection into an online form. That's the same level of attack. Why it's working? It's working because, of course, the model itself can be compromised. That's a structural problem of the model. However, it works as well because the data stream who is coming into the model is not depoisoned. Very simple. The poisoning patterns, the disturbance patterns are always there. They're part of the camera perspective. So how you can prevent this kind of attack, and it's very simple. It's like it works only because to be effective, the disturbance must be as well transferred or encoded very perfectly into the image. So let's say it from a mathematical level, there's a level of information as a disturbance you have to calculate into the image. If the level of information is there, we can manipulate the model. If the level of information of disturbance is under a certain threshold, it will be no more effective. And now we have the situation that there is a balance between what is the accuracy of your model towards robustness and the way how this model can be disturbed. And there's a certain level where you say, well, if I reduce the information in the picture, I'm reducing as well the disturbance which has been calculated in there. And that's a little bit, you need to try it out. And I mean, you need testing, but then you will find out there's a level of where the accuracy of your model is not really effectively changing, because you're just reducing the level of information of your input data. But you're reducing effectively the disturbance which have been placed by the attackers in there. By that, the adversarial attack will be ineffective, so your data is depoisoned. Like you have escaped out the disturbance. However, it will have an effect on the accuracy of your model. And there's one example. It's just simple. If you take the original picture of this bird, there's the disturbance in there, and then what you can do is just reducing the bit depth of this picture, like do it as a 6-bit color, 4-bit color, 3-bit, 2-bit, or you can do this kind of smoothing. The effect is always the same. The disturbance pattern is reduced as well, like the image is getting reduced. And now the big question is like how this will affect the regular accuracy of your model. And for example, if we take the 6-bit reduction, the models are still very accurate on identifying this picture as a bird or a specific bird. And however, the adversarial attack is completely out of order. It's depoisoned. There's still a pattern in there, but as the pattern has been as well reduced, it's no more effective. So this is a very simple way of depoisoning your input data and be sure that an attacker can't use an adversarial attack. Okay. Next thing, because I have 2 minutes left, but this was the main part, now more the fun part. I mean, and everybody is talking about ChatGPT and large language models and so on. We know a lot about how these models are working, and as well what are the problems towards them. And this is more a regulatory perspective, like what should a model, what is the output level the system should provide you. And what we see is like that you need to implement as well a procedure of responsible disclosures. And that's what's happening now on Reddit. On Reddit, we have perfect boards where people are they're playing around with ChatGPT and trying to find out how can we cheat all the filters, input filters who have been applied on ChatGPT to filter out, let's say, the unwanted, more unethical or regulatory critical questions for the bot. And if you're an operator in this kind of public space where you're creating this kind of public input and large input, what you need to implement is as well a culture of responsible disclosure, like we have in the software industry as well, so that people who are finding the weak spots of your model, that they are not using it and posting it on any darknet forums or whatever. No, that is people have a place where they can post it publicly because they are proud they have found out something which is super cheaty. They have found out a cheat. And however, that you have the team and the responsibility to review all these disclosures and then implement your risk mitigation on that on a certain time. And for ChatGPT, OpenAI doing that very well. So there's a very popular board on Reddit where people are just posting stuff like that, like there's an ethic filter in there, of course, that the system should not provide you any tips on how to discriminate people best, giving you advice how to discriminate people. Okay, if you do it as a direct input, it was not working. If you say ChatGPT, give me a Python code who's doing that, so the indirect way, which the system was not able to get a context on that, it was working perfectly, so writing your Python code on how to discriminate people. However, what OpenAI needs to do is to implement this kind of filter technologies. However, there's still a lot of bias with this filter apply system as well, and that's why you need to implement it really very good to to your teams and procedures. That's as well one example. So if you ask ChatGPT to tell a joke about women, it will tell you, no, that's not very nice. You should not discriminate anyone because the filter has been set from a certain bias. Obviously, the bias was male, because if you ask the system to tell a joke about men, it's very proud to bring you a joke, which is not very funny anyway. But however, you can bypass easily that bias. And by that, thank you very much.
Thank you very much, Mirko. I thought that was a fascinating talk, and I do want to see if there's any questions for Mirko from the group here. Please, gentleman in the striped shirt.
Yeah, very interesting. I have a lot of thoughts and questions here, but perhaps like two thoughts. You know, now with ChatGPT, my understanding is that as you are creating the instructions and you fine-tune the models and so on, you're adding something to the model. And are you aware of adversarial attacks there? Like, is that how would that look like?
Yeah,
and maybe quick, or maybe you can answer.
Yeah. The main problem with OpenAI, and this is really the big discussion, that OpenAI is not open. So let's say there's one critical fact, like, because these are this kind of large models. So the question is, what are the training and the data sources of these large models? So they have a supply chain for the data. I mean, that's what we know for sure, just to acquire all this data. So what they need to ensure is that this supply chains and suppliers are trusted. But if you outsource to Kenya, for example, to some cheap keyboard workers and whatever doing the classification, this is might critical, because it's very far away. The way how data is classified and proceeded is maybe very far away from OpenAI as a company in the Silicon Valley building the model. So for them, it's really challenging to keep a secure supply chain. And if I would like to inject a backdoor in this kind of models, the best would be maybe picking one of the suppliers who are doing this classification as this clickworker models, very cheap. But in large amounts. So this is really a problem, and as we can't look into the model to prove it, in that way, it's still very valid to say, if you haven't trained the model yourself, don't trust it.
Okay, I was probably referring more to when you do have ChatGPT 4 and you do start including instructions and you add to it, so that layer of which you can be fully responsible for. There's a question, if you don't have the full overview, or if you automate those instructions or prompts, based on customer feedback.
Yeah, but there we have this very, very prominent example, and I think the industry has learned from that, was Microsoft Tay. I mean, they were training Tay over Twitter. We know Twitter is never a good idea. And this was a wrong setting of the training, let's say the training specification, and then they were wondering that Tay was getting very rude within a couple of hours, because they were never thought about that there were boards online in the internet where people are just as grouping themselves, like to make a crowd attack on a model. We haven't seen any crowd attacks on ChatGPT yet. And maybe I think the model will be as well very robust, because it's much bigger than Tay on its time. But however, there are always ways of attacks you don't have in mind. Like Microsoft had in mind with Tay that people could go for Reddit and say, well, let's make a fascist, racist, really ugly chatbot out of Tay. But however, we'll see.
When I did have another question, now I start to change that to another question, but I was thinking of when you have the, if you retrain and introduce backdoor attacks, then basically the one that's training the model is having control of the data. So I'm not quite sure how that would work, other than having a type of industry spy that starts to introduce data before the data, before this training. If you have capable engineers that should be able to see what you... That was one question.
Yeah, but I can answer that. Like, if a model is compromised, let's say if you assume that a model is compromised by a backdooring, if you have access to the model, I mean, the question, do you have access to the model, yes or not? you have the ability to find out if there are malicious structural elements in the model. You can identify now with a very high accuracy if there are possible backdoors in your model in there. That's a good, let's say that's a good news. As well, like from the current research perspective, we have as well the, let's say, some certain algorithms and tool for the retraining to turn the model back again in a status which is, let's say, less malicious in this way, so where the backdoor will be no more effective. But however, the problem is the retraining. Like you're retraining and depoisoning, you need to identify where was the injection of the backdoor, because otherwise it will be just, it's like a malware. I mean, you have applied the malware removal, it will become back again with the next iteration then.
Well, thank you very much. I'm mindful that we need to crack on with the next session,
Yep.
but thank you very much for an insightful talk and for your questions. Thank you. Right, so from one cybersecurity expert